So today we are going to discuss about nanotechnology. Okay, so what is nanotechnology? So nanotechnology, nano means what? Small particles. Okay, so study of about the small particles. What are the small particles? Small particles are nothing but they are like quantum dots. Okay, so nanoparticles means very small particles which we can't even see with our eye. Okay, so if you see while sun rays are passing, okay, in that sun rays you can see small particles, no? So the nanoparticles are in the range of 1 to 100 nanometers. 1 to 100 nanometers. The particles which are in the range of 1 to 100 nanometers are known as the nanoparticles. Okay, so we will measure those nanoparticles with the 1 to 100 nanometers range only. Okay, if you see the properties, so what are the properties of this nanotechnology means, the properties, it is a size dependent because it should be in this range only. If you see the properties of the nanotechnology, it is size dependent. Why is it size dependent means it should have the size which in the range of 1 to 100 nanometers only. That's why nanoparticles are size dependent particles. Okay, and they also exhibit electromagnetic nature, optical nature. Okay, so the nanoparticles they have the properties of electromagnetism and optical nature also. Okay, and these are become more, the nanoparticles become more chemically active, means what? They have chemical properties also. They become more chemically active at nanoscale because of large surface area. So for example, if you take a ball and if you measure the ball surface area, if you keep the ball here and you measure the ball surface area, see for example this is the bottle. Okay, so if you measure like this, the surface area of the bottle is less when compared to if you cut the bottle into small nanoparticles, and if you measure the surface area, then the surface area will be large, right? So in the same way, nanoparticle surface area is large compared to its original surface area. Okay, so another important property is nano particles surface area is large. Okay, nanoparticle surface area is large and it is size dependent. It also exhibits electromagnetic properties, optical properties, and also chemical properties. Okay, it also exhibits all these properties. Which one? Nanoparticles. So what are nanoparticles? The nanoparticles are nothing but small tiny particles which are in the range of 1 to 100 nanometers. Okay, so if you see nanoparticles, nanomaterials, all are same. Okay, names are different, that's all. Okay, these nanomaterials are classified into 4 types. What is nanomaterial? If all the nanoparticles, if you put together then it will become a nanomaterial. Okay, so the nanomaterials are classified into 4 types. So what are those means? Zero dimensional nanomaterial. Okay, zero dimensional nanomaterial, 0D, one dimensional nanomaterial 1D, two dimensional nanomaterial 2D, and fourth one is three dimensional nanomaterial 3D. Okay, so these are the types of nanomaterials. First one is zero dimensional nanomaterial, one dimensional nanomaterial, two dimensional nanomaterial, and at last is the three dimensional nanomaterial. So what is this one dimensional nanomaterial means? The nanomaterial whose all dimensions are within the nanoscale. Okay, what is one dimensional nanomaterial means? Whose dimensions are within the nanoscale. So zero dimensional nanomaterial means the nanomaterial whose all dimensions are within the nanoscale, means within the nanoscale, if the dimensions are within the nanoscale, then it is zero dimensional nanomaterial, and one dimensional nanomaterial is if one of its dimensions is out of the nanoscale. Okay, if one of its dimensions is out of the nanoscale is called one dimensional. And the examples for zero dimensional nanomaterials are carbon quantum dots. Examples is carbon quantum dots. Carbon quantum dots. Okay, so this is zero dimensional. And one dimensional nanomaterial, the nanomaterial whose one dimension is out of the nanoscale, then it is called the one dimensional nanomaterial. The nanomaterial whose one dimension is out of the nanoscale, then it is called one dimensional nanomaterial. And examples are nanowires and nanotubes. Okay, so in same way 2D means two of its dimensions are out of nanoscale, then it is called 2D. And examples for 2D are nano layers and nano coatings. 3D also the nanomaterials whose three of its dimensions are out of the nanoscale are called three-dimensional nanomaterials. And examples for that are bulk of nanomaterials and bundles of nanowires. Means if you take in 3D, if you take bundles and bulk of nanomaterials, then it is called three-dimensional. Okay, so this is about types of nanomaterials. Okay, nanomaterials types. So what is we have seen what is nanotechnology and where we will use this nanotubes and all. So for example, in medical field also, during heart surgeries and all, they will place a stent, no? So they will pass that's run through a small nano tubes. Okay, so these nanotubes are made up of carbon atoms. Okay, and next is the applications. So next is the applications. So what are the applications means? These carbon nanotubes are used in transistors. Okay, these are used in transistors. So these are also used for filling. For example, if you take a cricket bat, okay, that cricket bat is very weight, no? So the inner part of the bat is filled with this nanoparticles. For filling purpose also we use the nanoparticles. Okay, so if you take the examples, these are used in transistors and also cathode ray tubes, electronic devices. Cathode ray tubes means CRT tubes. Okay, cathode ray tubes, transistors, cathode ray tubes, electronic devices, and lithium ion batteries. Okay, these are used in transistors, cathode ray tubes, electronic devices, lithium ion batteries, electrochemical and biosensors. Okay, so if you see the examples of these nanoparticles, they are used in transistors, cathode ray tubes, electronic devices, lithium ion batteries, electrochemical and biosensors, and they are also used like electrical shielding applications. So means in order to avoid the electric shocks, okay, outer shield will be provided to the wires, no? In that place also these nanoparticles are or nanomaterials only used. Okay, so these are the applications of nanoparticles. So if you see the nano devices, so these nano devices are used in ultra high definition displays. So these nanomaterials or nanoparticles are also used in the ultra high definition displays. So where we will use high definition displays. So for example, if you take like our OLED TVs, orthogonal LED TVs and QLED TVs, quadruple LED TVs, in those displays these nano devices are used. Okay, why? Because in OLED and QLED, if you see the picture quality and the resolution of the picture is more compared to normal TVs. Okay, this OLED and QLED TVs, the picture quality is the resolution is very good when compared with other TVs, right? So that's why these nano devices are used in ultra high definition displays also. Okay, so we know that OLED, QLED TVs are costly when compared to remaining TVs, right? Because in this they will use the nano devices, and those nano devices will provide the high definition displays. Means what? If you observe, the picture quality is improved, and also sound, the bass of the sound is improved, and when you see, your sensitivity of high eye is also improved if you watch in this QLED or OLED TVs. That's why now we are all are taking this high definition TVs, right? So next it is also used in drug delivery systems. So these nanoparticles are also used in drug delivery systems. So where this drug delivery systems means, for example, if people are treated for tumors and cancers, right? So how they will remove the tumor or cancer cell. So if there is a cancer cell in the body, if there is a cancer cell here, then using this nano devices, the anti-drug for the cancer should be projected on this part only. Okay, if the drug was projected on the remaining parts also in our body, the organs will be lost, right? So in order to avoid that, so using this nano devices, the drug delivery system, it is only the anti-drug is only projected on the part which is affected, okay, so that the anti-drug will not goes to the other parts of the body. Okay, understood? So it is also used in the drug delivery systems. Okay, and this nanotechnology has energy applications for clean environment also. For maintaining the clean environment also, these nano devices are used. How they are used means, they are used in the power plants, where we will get the power from substations, from where substations will get the power, they will get from the power plants, right? So this nanotechnology can also be used in the power plants to separate carbon dioxide also. Okay, to separate the carbon particles we use the nanoparticles. Okay, and means for environment friendly also these nanoparticles are. Okay, and it also improves the efficiency of fuel production from raw petroleum. So from raw petrol, okay, they will filter the raw petrol using these nanoparticles only. If there are any other dust particles in the petrol, then that petrol will attach to that nanoparticles and you will get the filtered petrol, means pure petrol out of it. Okay, so these nanoparticles are also used as a filtering agents. Okay, these are the best applications of nanoparticles or nano devices. Okay, so this is about nanotechnology.